Welcome to the deep dive. So if you're trying to keep up with enterprise AI, well, 2025 is definitely a year to watch. Retrieval-Augmented Generation, RE, and these agentic AI architectures, they're not just buzzwords anymore. They seem to be becoming really fundamental for businesses. Think of this as, your quick guide to understanding these big shifts.
Absolutely. And that's what this deep dive's all about, really, clarity. We're really focusing on why RAG is becoming, well, the go-to, it seems, and also how these agentic workflows are actually, maybe surprisingly, cutting deployment costs for sophisticated AI. Our goal is just to give you the key insights so you feel confident navigating what's happening.
Right. And for today's deep dive, we're looking at an article from DataPro.News. It's called RAG, the gold standard for enterprise AI. Seems like a good snapshot of where things are now and where they're heading. So, okay, let's jump in. First topic, multimodal RAG. I think most people, when they hear RAG, think text, right?
Yeah.
But that's changing.
That's exactly right. Yeah, the article really emphasizes this shift away from just text-only systems. Modern RG, it's now pulling in all sorts of data types. You've got images, audio, video, even like structured data from databases. It just allows for a much, much richer retrieval. You're getting insights you'd totally miss with just text.
That sounds incredibly powerful.
Yeah.
I mean, can you give us some specific example? How does integrating all that data actually make a difference?
Sure. The article has some really compelling ones. Take healthcare. Multimodal RG is apparently speeding up diagnostics by up to 40%. It does this by looking at patient records and medical images simultaneously. Imagine a doctor seeing connections between, say, notes in a report and patterns on an MRI almost instantly.
40% faster. Wow.
Yeah. And in finance, they're using it to cross-reference market reports with real-time trading data, trying to spot those crucial signals faster. And like in industrial settings, it's integrating sensor readings from machinery with the maintenance manuals, so you get much better predictive maintenance.
Okay, 40% in diagnostics that's genuinely a game changer. But handling all those different data types together sounds like a huge technical lift. What are the main hurdles for the engineers building these systems?
Well, the article points out it takes some pretty specialized skills. Data engineers need to be able to process and index all these varied formats efficiently. And crucially, without slowing down retrieval, a key idea here is creating unified embedding spaces.
Unified embedding spaces. Okay, what does that mean in practice?
Think of it like creating a common language for the AI. So instead of text, images, audio being totally separate things, you create this shared meaning space where the AI can understand the relationships between them. Text about a dog, a picture of a dog, the sound of barking they relate in this space.
Okay, that analogy definitely helps. Now, the article also talks about real-time domain-specific integration. Keeping the AI's knowledge current sounds absolutely vital, right?
Oh, absolutely. It's a major point in the article. They contrast the old way static knowledge bases, basically frozen in time, with these new dynamic auto-updating knowledge graphs. In fields that change super fast, having the absolute latest information is critical. Think about legal AI. It needs to know the latest rulings, the newest precedents.
Right, not last month's rulings.
Exactly. Or financial models, they need to adjust risk based on market shifts happening right now. Even customer support. Imagine the system instantly knowing about the features in the product update that just rolled out. No more digging through old PDFs.
So how do they actually do that? Keep it all current and accurate in real time? What's the tech involved?
Yeah, it takes some pretty sophisticated data pipelines. You can think of them as these constantly flowing streams feeding information into the system. They ingest, process, and index new data incredibly quickly. But data engineers have this balancing act. You need the freshest data, but constantly updating everything is computationally expensive. So they often use what the article calls hybrid search techniques.
Hybrid search, like combining different methods.
Exactly. It's like using a mix of tools, understanding the meaning of words, that's semantic search, using mathematical representations of data, that's vector search, and, good old keyword matching. Using them together helps make sure you find the relevant info, no matter how it's structured or phrased.
Okay, got it. Now, here's something that really jumped out at me from the article. Speculative RAG. It sounds, pretty cutting edge. What is that exactly?
Speculative RAG, yeah, it's a really interesting architectural pattern. It basically splits the retrieval process into two main stages. First, it uses several smaller, faster ARG models. Each one works in parallel, quickly drafting an answer based on different bits of the available data.
Okay, so multiple quick drafts happening at once.
Right. And then a second stage kicks in. A larger, more powerful language model acts like a reviewer. It looks at all those initial drafts, verifies them, and picks or synthesizes the best final output.
Huh. So it's kind of like a quick brainstorming session with several junior AIs, and then a senior AI comes in to check the work and finalize it.
That's actually a great way to put it, yeah. And the article shows some pretty impressive results, up to nearly 13% improvement in accuracy.
13%, wow.
And maybe even more striking, a 51% reduction in latency. So how long it takes to get an answer for complex questions. That parallel processing lets it explore more possibilities faster, reducing the risk of missing something important.
That really is a big jump in both speed and accuracy. What does this mean for the data pros implementing it, though? Does it make their job harder?
It definitely requires careful orchestration. They need to manage how these parallel workflows run, how the smaller models operate, and then they need really solid evaluation methods to make sure that final output isn't just fast, but also accurate and relevant. So yeah, it's managing a more complex system, but the payoff seems to be significantly better results.
Right. Okay, let's shift gears a bit to agentic AI. The article talks about a major shift here, moving from AI just answering questions to AI acting more autonomously. What does that actually look like in practice?
Yeah, it's a big leap. Instead of just passively responding to a query, these more autonomous systems, sometimes called hyper-autonomous, can proactively spot opportunities, make decisions based on the data they retrieve, and then actually execute tasks to hit business goals.
Okay, like what kind of tasks?
Well, the article gives some good examples. In procurement, maybe an agent predicts future demand for supplies. Then it could potentially negotiate with vendors, maybe even manage inventory levels automatically.
Oh,
Or in workflow management, you might have an agent monitoring project timelines. It could spot potential resource gaps, maybe even reschedule tasks to keep things on track. And logistics is another one, dynamically changing delivery routes based on real-time traffic or, weather conditions.
so these aren't just chatbots anymore. They're taking initiative, they're doing things. What's the underlying tech that lets them do that? How do they go from understanding to acting?
Well, engineers need to combine the R capabilities. That's the understanding part. Accessing and processing info with other components. Things like planning algorithms, which let the AI set goals and figure out steps to reach them, and decision-making frameworks to help it choose the best action among alternatives. And crucially, mechanisms to actually interact with other enterprise systems, usually through APIs.
APIs, right? The digital connectors.
Exactly. APIs let the agentic AI talk to and control other software, like the inventory system or the scheduling tool. It's about giving the AI both the brains and the hands, so to speak, to operate within the existing business infrastructure.
Okay, building on that idea.
Mm.
The article then gets into multi-agent orchestration. This sounds even more complex, like teams of AIs.
It is, yeah. The article describes it as maybe the most sophisticated pattern emerging right now. It's essentially an ecosystem of multiple specialized AI agents. They collaborate to tackle really complex problems. Each agent might be an expert in one part of a bigger workflow. And then you need sophisticated ways to coordinate them, coordination mechanisms, event triggers, so they can hand off tasks seamlessly and work together effectively.
So it's like building a project team, but with specialized AI agents instead of people, each doing their part. Is this actually happening now, or is it more theoretical?
It's starting to happen. The article mentions an industry prediction. Something like 30% of Fortune 500 companies might be operating multi-agent systems by 2028.
2028. That's
Yeah.
really soon.
It is. The potential benefits are huge, though. Things like much greater agility, faster decision-making, tackling problems that were maybe too complex before. That's the driving force.
Makes sense. But managing that kind of system,
Yeah.
what kind of technical know-how does that require?
It definitely demands some specialized expertise. Things like distributed systems, managing lots of independent parts working together. Also, message passing protocols, basically, the rules for how these agents communicate reliably. And state management, keeping track of what's happening across the whole system as different agents do their work. It's complex stuff.
Right. And then the article goes even further, talking about self-evolving AI architectures, AI that not only acts, but learns and improves on its own, without constant human tweaking.
Exactly. We're talking about advanced agentic systems that have built-in self-improvement loops, often using techniques like reinforcement learning and autonomous experimentation. Think of reinforcement learning like training through trial and error with feedback. The AI tries things, gets rewarded for good outcomes, corrected for bad ones, and gradually gets better at the task.
So it learns from experience, essentially.
Pretty much. It allows the AI to refine how it works and become more effective over time without needing explicit reprogramming for every little improvement.
The article mentions some impressive results, like legal research agents getting more precise, customer service agents understanding product issues better. How does that self-improvement actually get built in, technically?
Data engineers are key here. They have to design really robust feedback loops. That's how the system learns from its successes and mistakes. They also need evaluation frameworks to actually measure if and how much the system is improving. And, importantly, secure ways to update the underlying AI models with the new knowledge it gains, safely and reliably.
Okay, we've covered a lot about the tech itself. How are companies actually implementing this stuff, especially at scale? The article brings up RAG as a service.
Yeah, that's a really significant trend. It basically lowers the barrier to entry. RAG as a service uses cloud platforms, AWS, Azure, Google Cloud, etc., to offer RAG capabilities. It's scalable, often more cost-effective, and it lets the company's development teams focus on building their application using the RAG service rather than building and managing all the complex ARG infrastructure themselves.
Right, offload the heavy lifting to the cloud provider. Makes sense. What are the main things companies need to think about if they go the RAG as a service route?
Well, the article points out a few key things. Elastic scaling is when the service needs to handle ups and downs in demand smoothly. Cost optimization is always big with cloud, understanding the pricing, managing usage. Seamless integration with their existing data stores is crucial. And of course, data sovereignty and compliance. Where is the data processed? Does it meet regulations like GDPR? That's huge.
Okay. The article also mentions hybrid architectures, though,
Yeah.
combining cloud with edge computing. Why would a company choose that more complex setup?
Hybrid approaches are about getting the best of both worlds, really. Sometimes you have specific needs that pure cloud doesn't fully meet. For instance, edge processing, doing computation closer to where the data is generated, like on a factory floor or in a retail store, can dramatically reduce latency. That's vital for real-time applications.
Right, speed matters.
Exactly. And doing computation locally on the edge device can also help with data privacy concerns. Maybe sensitive data doesn't even need to leave the premises. Meanwhile, you can still use the cloud for the heavy-duty computation, the big model training. And there are techniques like federated learning that let you train models across many edge devices without centralizing the raw data.
Interesting. But managing that kind of split environment sounds tricky. What are the main challenges there?
Yeah, it adds complexity. Key challenges the article mentions include reliable data synchronization, making sure the edge and cloud have consistent information, efficiently distributing updated AI models out to all the edge devices, and having robust failover mechanisms. What happens if the connection to the cloud drops
Yeah,
or an edge device fails? The system needs to handle that gracefully.
right. Resilience becomes key. Okay, one last major point from the article. Governance. It really stresses a governance-first approach, especially with these more autonomous AI systems. Why is that so critical?
Well, as these AI systems get more power to act on their own, the potential risks go up too. It becomes absolutely essential to ensure they operate ethically, reliably, safely, and within legal and regulatory boundaries. You can't just let them run wild. So the article details several crucial governance mechanisms. Things like strong input validation using guardrails to stop harmful or inappropriate requests.
Okay.
Output validation, too, checking the AI's proposed actions before they happen. Comprehensive logging is vital. You need an audit trail to understand what the AI did and why. And explainability mechanisms, tools that help us understand, at least to some degree, how the AI reached a particular decision or action.
So it's really about building in safety, accountability, and transparency right from the start, not as an afterthought.
Exactly. It's finding that critical balance. You want to enable innovation, let the AI do powerful things, but you need the controls in place to ensure it's used responsibly and effectively.
Okay, so let's try to pull this all together. It really sounds like the lines are blurring, doesn't it? Between RAG, which was about finding answers, and Agentic AI, which is about taking action.
That's definitely a key takeaway. Yeah, we're seeing a convergence. We're moving towards these integrated systems that can both understand deeply through RAG-like access to information, and then act intelligently on that understanding, answering questions and getting things done.
And what does this mean for the people building these systems, the data scientists, the engineers?
The skill set they need is definitely broadening. It's not just data engineering or MLOps anymore. They also need a solid grasp of systems integration, how different components talk to each other, and critically, a real understanding of the business processes they're trying to automate or enhance. You can't build effective agents without knowing the business context.
So it seems the companies that will really win with AI are the ones that stop seeing it as just a tech project and start viewing it as like a core integrated business capability.
Precisely. It's about weaving AI into the fabric of the business. And strategically choosing these architectural patterns, multimodal, speculative, agentic, multi-agent that fit the need, always balancing that need for innovation with strong governance, scalability with performance, and autonomy with the right level of control.
This has been incredibly illuminating, a real deep dive into where enterprise AI is heading, and it's moving fast. It's clear these integrated RAG and agentic capabilities have enormous potential to really change how work gets done. Definitely gives us all something to think about. How might these shifts impact your own work, your industry, maybe dig deeper into multimodal learning or multi-agent systems if that sparked your interest? The evolution clearly isn't stopping anytime soon. Thanks for joining us on the Deep Dive.